Hey guys! Welcome back to my channel. If you want more videos, please like and subscribe. Today we're going to be learning about linear transformations, specifically horizontal and vertical stretches, compressions, and reflections. Let's get started. So if you look at these two graphs, you can see that the first one right here is just a normal parent function. But the one next to it is a transformed function. You can see that the line is still in the same place. The y-intercept is still the same, but the line has it has a higher slope now. So this shows that the graph has either been compressed or it has been stretched to look like that. So that's kind of what that is. So in algebraic form, if the first graph was f of x is equal to x, then this next graph could be something like f of x is equal to 3x. And that shows that it has gotten compressed or stretched. Now, if I added like a +2 to the end, that would indicate a shift. So we would shift the entire graph up to, and the y-intercept would no longer be at the origin. So that's kind of what a stretch/compression is. So now let's look at kind of what reflections are. So for this first graph, it is a parent function. But the one over here, it looks like almost as if there was a mirror on each of the axes that reflected the entire line over to the other side. So that's basically a reflection. So algebraically, this would look something like this. We'd have our first one, the parent function, as f of x is equal to x. But then the second one would instead be f of x is equal to negative x. So the negative symbol right here indicates that there is a reflection. So whenever you see a negative in front of the variable of x, that means that there is a reflection. So these are the basics of stretches, compressions, and reflections. We'll learn more about them on the next page as we solve our practice problems. So here are our practice problems. Problem 1 says to fill out the table, and at the top of the table it gives us the base equation for a transformed function. K of x is equal to a times f times b times x minus c plus d. So in that equation, horizontal stretches and compressions are represented by the variable b. And vertical stretches/compressions are represented by the variable a. So whenever you see a number being multiplied before the actual f of x function, that means it's a vertical stretch/compression. And whenever you see something that's right outside of the x, that means it is a horizontal compression or stretch. Now for our reflections, if there is ever a negative b value, that shows that there is a horizontal reflection. And if there is ever a negative a value, that shows that there is a vertical reflection. So now that we've seen where stretches, compressions, and reflections are in our equation, let's move on to problem 2. So problem 2 says if f of x is equal to x plus 1, then write the new equation k of x after applying the given transformations. So the first thing we're going to want to do is identify which transformations are taking place. So the first thing that's happening here is a horizontal reflection. So with our horizontal reflection, it's also being multiplied by 2. So what the 2 multiplied by the x tells us is that this is a horizontal stretch or a horizontal compression. So you may be thinking that this is a horizontal stretch, but that's actually not the case. This is in fact a horizontal compression. And the horizontal compression is not by a factor of 2, it is by a factor of 1/2. So you guys may be wondering why. So when we have horizontal stretches or compressions, what we have to do is take the reciprocal of whatever number is being multiplied to x, and that will be our factor. So 2 is being multiplied by x. We already got the negative out of the way with the flexion, so all that's left is 2. So when 2 is being multiplied by x, inside of the parentheses, that shows us that it's a horizontal compression. Because if you take the reciprocal of 2, the reciprocal of 2 is equal to 1/2, and 1/2 is less than 1. Since 1/2 is less than 1, it's going to be a compression. So we can write over here that this is also a horizontal compression, and whenever you write a compression or stretch, you always need to write what the factor is. So this is a horizontal compression by a factor of 1/2. So those are our transformations that's being applied to this graph. So now we need to write the new equation that will come after this. So what we're going to do is set our new equation, which is going to be k of x, equal to f of -2 times x. And next we're going to write that k of x is equal to, and we want to get rid of this f right here, so we're going to write -2 times x, and we're going to keep that in the parentheses, and then we're going to add the +1 to the end, because remember, the original parent function is f of x is equal to x plus 1, not just x. So we're going to add that 1 to the end after that, and now we're just going to simplify, and we're going to get k of x is equal to -2x plus 1. And that is our final answer for this one. So our next one, we have, again, a number being multiplied by x inside of the parentheses and a -4 outside of the parentheses. So let's work on inside of the parentheses first. We see that whatever is inside the parentheses will be horizontal. So since x is being multiplied by 1/2, we need to take the reciprocal of that to see if it is a stretch or a compression. So the reciprocal of 1/2 is equal to 2. So it's going to be a horizontal stretch by a factor of 2, because 2 is greater than 1. So basically anything less than 1 is going to be a compression, and anything greater than 1 is going to be a stretch. So this one is a horizontal stretch by a factor of 2. So with the -4 over here, this one is a shift because it's not being multiplied by anything, it's actually being subtracted. So it's not a reflection, it's actually a shift. And you're shifting this, since it's outside of the parentheses, you're vertically shifting this down 4. So these are all of the transformations that are being applied to this. So let's write our new equation. So we have k of x, and we're going to set that equal to our original, which is f of 1/2 times x minus 4. Okay, and now we want to get rid of that f right there, so we're going to write it as k of x is equal to 1/2 times x, and then we're going to add the +1 to the end, and that entire f of x is being subtracted by 4. And so now we're finally just going to simplify, and we're going to end up getting k of x is equal to 1/2 x minus 3. And that is going to be our final transformed equation for this one. The next one, we see a -3 being multiplied by the entire f of x function. So first thing we need to address is that negative right there. Since the negative is outside of the parentheses, we can conclude that this is a vertical reflection. So that is one of the transformations. Then we also have 3 that's being multiplied by f of x. Since the 3 is outside of the parentheses, this is going to be a vertical stretch or a vertical compression. So vertical ones are actually pretty straightforward. If it is greater than 1, it's going to be a stretch, and if it's less than 1, it's going to be a compression. So for vertical ones, there is no need to take the reciprocal. So for this one, it is going to be a vertical stretch, because 3 is greater than 1, by a factor of 3. So there's no weird stuff you need to do with the vertical transformations. Those ones are pretty straightforward. So we have these 2 transformations affecting this, and so now we're going to start writing our new equation. So we're going to set k of x equal to negative 3 times f of x. So we want to get rid of that f of x, so we're going to say k of x is equal to negative 3 times, and then f of x is equal to x plus 1. So we're going to say negative 3 times x plus 1. So now we need to simplify, and we're going to end up getting k of x is equal to negative 3x minus 3. And so that is our final answer for this one. So now that we've seen how to identify and write new equations with a given transformation, let's go to the next one and see our next problem. So over here, problem 3 says, explain what transformations have occurred in the original equation if the parent function is equal to f of x is equal to x. So this one has a normal parent function with no extra add-ons on the end. So let's look at the first one. So the first one starts off with k of x, so you know it's already been transformed. So it says k of x is equal to 2 times f of 3 times x minus 4. So over here, the first thing I see that's affecting this is the 2 that's being multiplied by the entire f. So that 2 right there signifies that there is a vertical stretch by a factor of 2. So the next thing I see is that 3 that's being multiplied to the entire x minus 4. So since the 3 is inside brackets, we can say that is a horizontal something. So remember, for horizontal stretches / compressions, we need to take the reciprocal of it to get the factor. So the reciprocal of 3 is 1/3, and since 1/3 is less than 1, we're going to say this is a horizontal compression by a factor of 1/3. The next thing that's affecting this is the 4 that's being subtracted from the x inside the parentheses. So this is going to be a horizontal shift because it's being subtracted and not multiplied. So it's moving positive 4, and positive indicates a right direction. So that means it's going to be a horizontal shift right 4. And those are all of the transformations that are occurring in this first one. Let's move on to the next one. It says k of x is equal to negative 1 times f of x plus 1 plus 5. So for this one, we have a negative 1 that is getting multiplied to the f of x. And since it's being multiplied, we know that it's either a stretch or a compression. But if you actually look at the number it's being multiplied by, it's actually only being multiplied by 1. 1 leaves it exactly the same thing as it was. So it's not really getting stretched or compressed. The only thing that's happening here is since it's being multiplied by a -1, we take that negative as a reflection. So this entire thing is being vertically reflected. So that is one of the transformations that's occurring, a vertical reflection. The next one I see is the +1 inside of the parentheses. Since it's inside the parentheses, it's going to be horizontal. And since it's being added, it's a shift. And to get the direction, we flip the sign since it's being added. So since the sign is positive, we're going to make it negative. And the negative direction is left for horizontal shifts. So it's horizontally shifting left 1. The last one I see is a +5 outside of the parentheses, so that indicates a vertical shift. And remember, with vertical stuff, it's pretty straightforward. So since it's a +5, the positive direction is right. So it's going to be a vertical shift right 5. And so that gives us all of the transformations that are occurring here. So that's it for today, guys. If you like my videos, please be sure to like and subscribe. Also, be sure to comment any other topic ideas you would like me to cover, and drop any questions you have in the comment box below. Thank you so much for watching. See you next time. Bye!